Hello, my name is Melvin, and I'm going to do my second quality assessment in information storage management. So, what we're going to see is storage system used in Cardonia. So, what is a storage and why storage? Actually, see, there are different types of storage. We have seen a lot of storages like magnetic tape was the first one to use it, and then cassette, and then floppy disk. And we are familiar with floppy disk, and now hard disk, and now we have SSD and stuff, all things like that. So storage devices are getting better and better in time. And what we are going to see is hard drives. So hard drives, there's not a clear picture in here, so I'm going to give a PPT which is given by me as well. Yeah, this is a physical disk structure. So this is the spindle here, and the track, sector, and cylinder. This is a cylinder. So we're gonna see it one by one. So platter, it is a HDD. Typical HDD consists of one or more flat circular disk, and it is a set of rotating platters sealed in a thing called head disk assembly, and data can be written to or read from both the surface of the platter. So number of platters and storage capacity of each is determine the whole total capacity of the drive. So next is a spindle. A spindle is the one which connects the platter together, and it is connected to a motor. So the spindle spins and the disc rotates. That's the what you can hear. So the disc drive spindle speeds of 7,200 rpm or 10,000 or maybe 15,000 rpm. It depends upon the disk drive. So read write head. This performs the read write head as per the platter is on the surface. So uh, yeah, during the read writes, the read write head never touches the surface of the platter. So when the spindle is rotating, there's a microscopic arc gap between the read write heads, and the platter is known as the head flying height. And if the drive malfunctions and the read write head accidentally going to touch the surface of the platter outside the landing zone, a head crash occurs. Okay. Then there's a actuator arm, which is the read write heads are mounted on the actuator arm assembly, which positions the read write head at the location of the platter where the data needs to be written or read. And the controller is a printed circuit board mounted on the bottom of the disk drive. It consists of microprocessor, internal memory, circuitry, and firmware. So the logical block addressing this is pretty tough. So you're gonna read it on your own. And yeah, the disk drive performance is depends upon the device. So if it is an electromechanical device, the impacts the overall performance of the storage system. And the service time, this service time is depends upon the seek time, rotational latency, and data transfer rate. So that's all given here. And so then the types of connector. So different hard drives and stuff, magnetic tapes, all those kinds have different types of connectors. So as you can see, these are different types of connectors. So that's all you can see. And yeah, the next is RAID, which is going to be said by my teammate Joshua Alfonso Mario. So peace out.
So, in continuation with what Melvin has told us already, I will be talking about the different RAID types that are being used in Carmio. So, basically, there are two types. One is hardware and one is software, and they are classified into various levels: 0, 1, 5, and 6. So, the first RAID level is the basic version where data is basically just striped across a series of disks. But this has a lot of disadvantages because data can be lost, and it's also very costly. But as in RAID 1, the data is mirrored onto another disk. So there are two copies of the same data made on two disks each. So this would minimize data loss, increase efficiency, but this would prove to be more expensive than RAID 0. RAID 1.0 combines the features of both striping as well as mirroring. So the data is striped on one disk, on one set of disks, and is mirrored on another set of disks. So this somewhat reduces the cost burden that is being produced by RAID 1 and RAID 0. So it's uh, it's a much better alternative when compared to RAID 1 and RAID 0. In spite of all these things happening, there are the errors in parity bits. There are errors in data which happen when the data is being written to the disk. So in order to circumvent this problem, a parity bit is added to each of the disks uh, across all drives. So as you can see, this RAID 5, uh, each of the drives has a parity bit in order to ensure that the data remains does not get corrupted. So to go more in detail, let's have a look at this PPT here. As you can see here, there's a parity generated from the host, and this would prevent data from being corrupted. And RAID 5, independent disks have distributed parity, so there are more than one parity bits on various drives. So this is kind of expensive, more expensive than RAID 3, but its performance is one of the best when it is compared to the other RAID types. And RAID 6 deals with dual parity RAID. So suppose two disks fail in a RAID, then it leads to data unavailability. But if you increase the number of drives in an array and the drive capacity increases, so there's high probability of two disks failing in a RAID set. So RAID 6 protects against two disk failures because it maintains two parities, and it has a horizontal parity which is same as the RAID 5, and a diagonal parity which is calculated by taking diagonal sets of data blocks from the RAID set members. So if you have a look at the RAID comparison here, you can see the number of disks, a minimum number of disks required, the storage efficiency, the cost, the read and the write performance. As you can see here, 1 plus 0 and 0 plus 1 striping and mirroring has the best here. You need minimum 4 disks. The cost is high, but the read performance and the write performance are very good. But if you want to look for cost efficient RAID disks, then you can go in for either RAID 0 or RAID 3. So that's it for my part, and the rest of the topic will be covered by Jones.
Hello sir, this is Jones. I'm going to continue what Mario said. We are going to see the types of storage technologies now. So here we are going to see DAS, SAN and NAS. These are used in our Carmia, sir. So we are going now. Direct attached storage. Direct attached storage. So DAS is basically the cables through which everything is connected. Okay. Next we are going to NAS. So in NAS, what happens is first we have the server, then we have the clients, then we have the Ethernet network switches, and the network attached storage. So this storage is there in our CTC. Then we have the server and we have the client switch, which is our laptops. The switches are provided in our hostels. Okay, that's basically NAS. So in NAS we have two more types: integrated NAS and gateway NAS. So in integrated NAS, it's actually kind of like a direct connection. So there's a system, an IP, and NAS device. This is provided in Vinod Divat's table. Okay, and this is gateway NAS. Gateway NAS is actually what we get. So like we have an IP, we have a NAS head and FCN. Scan. So the NAS head connects to the storage array instead of a NAS device. Okay, and this is for the clients. Similarly, what happens? We have a storage area network. In the storage area network, actually what happens is that there are a lot of clients who are connected to a switch, who are connected to switch to the server. Okay, and we have the ICIS, CSI targets, the FC switches, finally leading to the server. So to the main concept of the storage area network is to provide the client connection with the server. Okay, then we have the types of SAN connections. The SAN connections, there are actually the storage array, which is SAN islands, FC abbreviated loops, and similarly there are two more types. Okay, this is a simple structure which has only FC hub. And in the second type we have a FC switch, FC hub and FC switch. Both we have switches and hubs. Okay, in the third one we don't have any hubs, we have only the switches. These are enterprise SAN FC fabricated switches, so only switch will be there. This is a combination of switches and hubs. Next we have the SAN interconnectivity options. SAN interconnectivity options actually provides connection between two directors or not two directors. So first we have one director and we have various switches. Next we have two directors connected by many different switches. Okay. Next, why do we use server? So why do we use server? Servers basically stores many things for us. So the main concept of the server is remote access. That's what we are using, and we can store like hypertext transfer protocol, file transfer protocol. These are used to access the server. SMTP mail protocol, POP3, then message access protocol, file sharing protocols. Everything is there. These are used to access the server. That is the net protocols used to access the server. Through this, we can access the server. Okay. Next, we have cloud storage. Cloud storage basically it has three types: file storage, object storage, and block storage. File storage. File storage, data is stored in the form of file, similar to our Windows systems. Okay. For example, for this is Amazon EFS, Azure File Storage, and Swift. Okay. Next, we have object storage. Now, object storage, data blocks are saved within sectors and tracks. An example for this is IBM Spectrum Scale, Dell EMC, Elastic Cloud, and so on. Okay, so this provides concurrency across the entire data. Then we have the block storage. Each block storage acts as an individual hard drive. So this is similar to our RAID. Okay, like we have individual storage of these things and all, and it can be accessed by the FCOE, and ISCSI. And an example for this is Amazon EBS, Sender, Block, and so on. So that's all, sir. Thank you for watching.